Okay, so we're going to do another video on logarithms. We're going to cover the rules of logarithms, and the rules of logarithms come from the rules of exponents. So first of all, let's review the rules of exponents. So here we have some number that's not zero. Okay, so x is some number and it can't be zero. But we have it raised to the power 0. So for example, like 2 to the 0. And we know that 2 to the 0 is defined as being equal to 1. So any non-zero base raised to the 0 is equal to 1. And we can talk about why this is a little bit later. Okay, so that means that when we ask, remember, a logarithm is an exponent, so when we ask what log do we have to put on our base to make it equal to 1, the answer is 0. Okay, so b, when we're seeing a log, we're really being asked to fill in this little box right here, b to the something equals 1, and the answer is 0. Okay, awesome. So that's the first rule of exponents, and it gives us something that we might want to kind of remember about logarithms. Okay, second is that when you have x to some power times x to some other power, what is the rule here? So let's give a concrete example. So like 2 to the 3 times 2 to the 4. Really, that just means 2 to the 3 means 2 times 2 times 2, and then times for this times, and then 2 times 2 times 2 times 2. So you just need to count up the total number of 2's and say that, hey, we're going to multiply by 2 7 times. So the 7 just comes from adding the 3 and the 4 together. So what we do when the bases are the same and we're multiplying is that we add the exponents. Okay, so remember, logs are exponents. So if we have log base b of a times b, so if we're multiplying, then what we do is we add the exponent. So the exponent that would create the a is log base b of a, and the exponent that would create the b is log base b of b. So let's put this into a concrete example. So say we have log base 10. Now, when you have a base 10, you don't write anything down here, but I'm going to put 10 just to emphasize that our base is 10. And say you had 10 squared times 10 cubed. Okay, so there's two ways we could approach this. We could just say, oh, well, I know the rule of exponent is that you just take the 2 and the 3 and you add them together. And now there's two different ways we could look at this. We could either say, hey, this is asking us what exponent we have to put on our base to make it equal to this. Well, 10 to the what equals 10 to the 5. The what must be 5. Okay, and then let's go this way and apply our rule. So our rule says, hey, if you have a product inside your log, then you can take the log of each factor separately and then add the result together. So here, that would look like log 10 of 10 squared plus log 10 of 10 cubed. So the product becomes a sum. And then we can think here, what power do I have to raise 10 to turn it into 10 to the 2? Well, 2. And this almost feels like kind of weirdly like, well, it's already showing what I have to raise the 10 to make it 10 to the 2. And that's exactly right, because what you have here is the logarithm base 10 and the exponential function base 10. So you have a function and its inverse, so it's no real surprise that this is canceling out. So this is another way that you have of looking at this. And then over here, the power we have to raise 10 to make it into 10 to the 3 is 3, and then I'm supposed to add those together, and that gives us our 5. Okay, so that's our first rule of logs. It totally makes sense here when you've got the things written as 10 to the 2 times 10 to the 3, but you know, when you start writing just log of 8 times 3, that's really kind of mind-blowing. It kind of doesn't make so much sense anymore that this is log of 8 plus log of 3, but we could actually force it to make sense by realizing that the 8 can be written as 10 to the something, and that's really what we're looking for. So hang on a sec, let me get a calculator. You can get a calculator too, and take the log of 8. And what you get is log of 8 equals 0.903, and then it just keeps going. So we're going to just approximate. So what this means is that the power that I have to write on 10 to turn it into an 8 is 0.903, and then it goes 0899, and you need all of that because otherwise it'll only be like approximately equal to 8. Okay, so this sort of makes sense because 10 to the 1 would be 10. So we're close to 10 here, but not exactly. So we're raising 10 to a power that's a little bit less than 1, and it's becoming 8. Okay, and then log base 10 of 3, well, you can think of what that's going to be. Like so the square root of 10 would be a little bit more than 3. And remember, the square root is the same as raising 10 to the 1/2, so which is the same as raising 10 to the 0.5. So we should expect a number a little bit less than this, because 3 times 3 is 9, so 3 isn't quite as big as the square root of 10. So let's go log of 3, and then we get the answer of 0.47712. So even though this example here seems very, very different than this example up here, we can actually rewrite 8 as 10 to the 0.903, and we can write 2 or 3 as 10 to the 0.47712, etc. So now you can see, oh yeah, well, this would just be 10 to the power of these two things added together. So this example is actually exactly the same example as that. That's the whole weird thing about logs, is that you can find a number to raise 10 to turn it into 8, even though 8 is not a bunch of 10s multiplied together. Okay, so that's sort of the reasoning and some understanding behind this rule of logarithms right here, but you don't necessarily have to understand all of that. I just think it's always good to sort of see where things come from, but what you do need to know is how to apply this, which we will look at probably in the next video, so this one doesn't get too long. Okay, so the rule of exponents here is when the bases are the same and you're multiplying, you add the exponents, led to this rule of logs. So when you're multiplying inside the log, since the log are exponents, you can add the logs instead of multiplying inside the log. Okay, the next rule here is what do you do when you have x to the a over x to the b? Let's do an example again. So if we have like, let's do an example again. So if you have 2 to the 5 all over 2 to the 2, then basically the top represents multiplication. So you have 2 times 2 times 2 times 2 times 2, and the bottom represents divisions, 2 times 2. Well, multiplying by a 2 and dividing by a 2 cancels out. Multiplying by 2 and dividing by a 2 cancels out. And so we're just left with the 3 2's on the top. So the rule is that you take the exponent on the top and you subtract off the exponent on the bottom. So to get this, which is really equal to 2 to the 3, we could have just gone 2 to the 5 minus 2. That's the canceling that we did here when we subtract 2 off of there. So the rule is x to the a minus b. A minus b. And this leads to the next rule of exponents, which is that when you're dividing, of logs, when you're dividing, you subtract the exponents. And since the logs are exponents, you subtract the logs. Okay, that's the next one. Okay, and then I just want to remind you a couple other things about exponents. So now that we've seen that the rule for dividing is to subtract the top exponent from the bottom, let's think about why things to the power of 0 are 1. So if we have 2 to the 3 over 2 to the 3, well, all of the 2's are going to cancel out. We basically have 2 times 2 times 2, and we have 2 times 2 times 2. So we have 8 over 8. That's 1. Or you can think this is 1 times 1 times 1. Oh, the answer to all of this is 1. And then if we apply the rule, we take the top exponent and we subtract the bottom exponent, we get 2 to the 0. So 2 to the 0 equals 1. And that's by definition, and it sort of makes sense in terms of the pattern. Now, what happens if there's more 2's on the bottom? So you have 2 to the 3 over 2 to the 4. Well, let's just do it out the long way. We have 2 times 2 times 2 on the top, and we have 2 times 2 times 2 times 2 on the bottom. So 3 of these 2's pair up and become 1's. And then we have this 2 left on the bottom. So basically we have 1/2. So it's equal to 1/2. See, there were more 2's on the bottom than there are on the top. And if we use the rule, 2 to the 3 minus 4, you get 2 to the minus 1. So 2 to the minus something just means that 2's were left on the bottom. So the negative sign is commonly used to show the opposite. When the negative is out front, it's the opposite of adding. Okay, and so it cancels out adding. So if you have, say, 10 minus 2, and you're like, oh, wait, I didn't want to subtract 2, you add the 2 back, and so you get 10 plus 0, because these two add up to 0, and it's like you haven't done anything. So when you take a number and its additive inverse, you combine them together, you get 0, because 0 is the thing that when you add it, it won't make any difference. For multiplying, when you take 2 to the 1 and you multiply it by 2 to the minus 1, the rule is that you add the exponents, so you get 2 to the 0, which is 1. So these are multiplying inverses. So this is multiplying by 2, this is multiplying by the flipped version. It's called the reciprocal, and when you multiply a number by its reciprocal, you get 1. And again, if we were, say, had 10 here and we had multiplied it by 2 and we're like, darn, no, I didn't want to double it, well, then you can come and multiply by its multiplicative inverse, 2 to the minus 1. And then it's as if you had just multiplied your 10 by 2 to the 0, which is 1. So you haven't changed your 10 at all. So these two are sort of canceling each other out. So a number and its reciprocal, or a number and its multiplicative inverse. Those are the same thing. Okay, that's just a big mess. Let's get rid of a whole bunch of this. So x to the minus a is equal to 1 over x. And that means that log base b of 1 over x, oh, we could apply this rule. It's equal to log base b of 1 minus log base b of x. And then what is this? The exponent I have to raise b to make it equal to 1. Oh, that's 0. So log base b of 1 over x is just equal to the negative version of log base b of x. Another way you can see that is you can say, hey, wait, I know how to write this. 1 over x is the same as log base b of x to the minus 1. And then you're going to see the next thing that we're going to have is a rule is that if you have exponent up here, you can bring it out front here. So this minus 1 can come out front. But oops, I got ahead of myself. We haven't seen that rule yet. So actually, let's skip down to that rule right now. So the next rule is to the m to the r. So what do we do when we have x to the 2 to the 3? Well, you might remember that this is x to the 6. So x2 times x2 times x2, that's what this guy means. And what do we do when the bases are the same and we're multiplying? We add. So 2 plus 2 plus 2 is equal to 6. Or 2 plus 2 plus 2 is equal to 3 2's, which is equal to 6. So the rule here is that we multiply the m times the r. Okay, and that leads us to log base b of m to the r is we take the exponent of this guy, which is that, and we multiply it by the next exponent. So we multiply the exponents together. And remember, this is an exponent, so when I take this exponent and multiply it by this, I'm multiplying the two exponents together. So let's see an example that will make that more clear. So log base b of 10 cubed to the 5, well, you could go ahead and multiply inside here. So that would be log b of 10 to the 15. Oops, sorry, not b, let's make this 10. Log base 10. So what power do I have to put on 10 to turn it into 10 to the 15? 15. So I could go that route, or I could use my little rule. And the way that most people like to kind of think about this rule is that the power here can come down and go out front here. So this becomes 5 times log base 10 of 10 to the 3. Oh, well, the exponent we have to put on 10 to make it 10 to the 3 is 3, and then we'll multiply that by the 5. Okay? You could also do it here. You could take this out front. Here, oh, look, we could put the 15 out front, and then we're left with 15 log base 10 of 10. But what is the exponent I have to put on 10 to make it equal to 10? It's just 1. So you get 15 times 1 is 15. Okay, so that's another rule of logs that we have going. Okay, and I think that's it for our rules, and then we can come back in the next video and solve some problems with them.